Hello everyone. So we're live at YouTube. Just let me grab my phone as well. Give me a sec. Okay. So yeah, let's wait for others to join as well. And we can kick it off soon. Awesome. Cool. So let me prepare my slides and start sharing, plus going through the items that we've got. We want to wrap up the session today, wrap up the series I'm in. Let me close it and put it here. So guys, in the meantime, we can just say hi in the chat. Okay, this one and this one. We should be good. Cool. So yeah, while we are starting, we can wait also with for others to join. Let me share my screen and let's start with the slides. Awesome. So yeah, the session number 4 of DP-700 exam preparation series at Microsoft, actually at the Fabric Café, Microsoft Learn community, a learning room there basically, and we focus on Fabric and Power BI. We have the weekly sessions with almost 6,000 members around the globe, and here are our links and our presence in the social. The YouTube channel where you can just watch the past sessions or the upcoming sessions, including and actually the current one is going to be available on the live section. You can just follow us on LinkedIn and do the RSVP on Meetup, and make sure you're gonna rate the session. Thank you very much for adhering to the code of conduct of our community. And yeah, it is Mehrdad Abdollahi, the community lead and your instructor in this series. We have actually done another study for another bootcamp for DP-600, and today is the last session of DP-700 one. And we are going to just wrap it up, and we will talk about more detail actually on the streaming data. And also moving to the monitoring and optimization section. To just complete it, we will have some hands-on practice on KQL, and if the time allows, we can just have a practice on PySpark as well. actually I have a hard stop in 2 hours, so let's not waste the time and kick it off. Before I jump into the third section actually of the skills that you're going to talk about for the monitoring stuffs, I would like to just walk you through in more details on the real-time intelligence in Fabric and its components. And let's see what are the possibilities there for us and how we can make the most benefit of that. And if there is any tip, tricks, something like that, we can just learn them by doing them. I hope all is okay with the resolution, with the size of the screen. Anyway, we talked about the real-time intelligence previous week. We have created a event stream, which was this guy. The event stream was loading the data from a sample data for bicycles, and it is active, and data is landing through. And now we've got around, I think, 100,000 records in our database since last night. So we can deactivate it to just save the resources. We don't have to keep it live. So it is one of the stuff. So if you want to deactivate or activate your streaming or even the destination, you can just mark them as active or inactive. Anyway, the data is going to be started from a source, then a streaming processing that it is going to be followed by some transformation on the data. You can filter on that. You can aggregate it based on what you need, or even and sending it to a destination, or creating an activator on top of that. So the event stream has two views: live view and edit view. So if we want to change anything or change anything, we can just go to the edit, and also we can deactivate all at the same time by hitting this guy. And there is let's start from here. You can have some sort of static schemas, or reading the data from different schemas. Here you can just enable the multiple schema inferencing, and then if your source contains multiple schemas, then you can just enable it and specify the the schema that you're gonna have. So if you're applying that, it is going to be permanent enabled, and you cannot just revert it back actually. So, and how the schemas are going to be created: if you go to your workspace, you can search for schemas here, and however, it is in preview, but it is good to know the possibility of that. And the event schema sets, you can just say my schema 1, and when you create it, you can just start creating your schema, the name of the fields. It is actually a schema set. Then you can create one underneath of that, and then it will be the name of the files, the type of them as fields, and the type of them. Then you can apply this schema to your source when you are reading the data. When it is it makes sense to have a schema set like this. Maybe you can, when you are reading the data actually from an endpoint or from Azure SQL, for example. You can add your schema here. You can associate it to a stream or a table. Then you can manage the schema over time. So, just let's name it something, schema 01, and then you can just add the data type, a field name, and whatever that you're going to add here, right? It is going to be a nullable or not. It is, for example, a boolean, let's say b1, and if there is any description, then you can just add it. Another thing, for example, for a text 1 as a string, you can also make it nullable or not nullable, and then when you save it, it is going to be added to your schema set. So anyway, we can just add to your schema then, and it will be usable when you are adding a let me just bring it up, a source. When you're adding a source from somewhere, for example, I don't know, a custom event, then you can just activate that guy, the schema association to your data. However, it is inactive because let me just go to the live mode, because this multiple schema inferencing is not active. I think it is going to be good now. Then we can just add it. Let me check. Okay. After publishing. So if we go to this guy, all should be good at this. That's fine. I need to check something here. Cool. Yeah, that is why. So I just checked that, and yeah, noticed something. When you add a schema and you want to actually associate an event actually to your schema, it has to be for a new event stream and not for an existing one. So if we create a new stream, then we can assign that schema. Okay. So yeah, just good to know. However, it is in preview, and you don't have to be worried about that. So let's back to our event stream and see if there is any item. Okay, just while we are here, if you go with a custom endpoint source, it is going to give you, some information that if you want to push the data, actually stream the data to your event basically stream, you need some endpoints, the credentials, how to look for that. For example, if you want to push the data using your event hub, then the basic informations are going to be here. If you need to have the namespace endpoint, or for just doing the configuration when you are connecting your source to this event stream. Of course, you're gonna need this event hop name, or this shared access key name, or the primary keys or secondary keys, and the connection string when you want to connect to that. We have the same story for AMQP and for Kafka, Apache Kafka. So here, it has a bit, different things that basically you need to just, specify the bootstrap server, the security protocol, mechanism of that, and some other stuff like topic name that belongs to Kafka. What else? And I think, yeah, we're good with this. Just keep in mind, when you add a custom endpoint, you can always, get the information after publishing your event stream. You can just find them underneath here. Let's go to the settings section. If there is anything specific for the retention time, for how actually long you need to basically keep the data. And yeah, that's good, I think, for this one. And in the event in the edit section, let me just have a look at it to see if there is anything new that we haven't discussed yesterday. That should be good. Just one thing. You can also, as one of the steps for your transformation of the data, you can make use of SQL code. And for this one, you can simply just write your SQL code, and then just work on it and add your basically transformation. So I'm going to delete those guys that are not required. We have checked the data sources. Just one thing, if you need your basically your data to be to just go to in two destinations, we can just do something. We can only have one. No, yeah. You can just have two destinations at the same time. One, goes to the event house, and one goes to your lake house. So you can just set it up as well if you want your data in the lake house. But there are some ways to have your event house, your KQL database in one lake. Let's have a look at that one as well. If we just jump into our event house, which is the container of our KQL databases, then we can see some options there. So you can have your data. If we move to the event house, there is a button here for one lake, or even from this Eclipse, or by right click on that, you can find this one lake, and you can just say, hey, I want the whole database to be available on one lake. It is going to be a permanent thing, and we can apply to the existing tables or the tables that are going to be created afterward. However, when you do that, then you can see your tables are going to be available in the in one lake, and afterward you can see the files, right, that are sitting there without actually integrating that to your one lake. There is no possibilities of exploring the delta, the delta table views, and you cannot explore it. But after enabling the OneLake integration availability, then it will be added automatically to the OneLake, and it's going to be written there as well as a file. So yeah, now it is active. The policy updated succeed. Now that our data should also be in, let me just refresh it. And let's check. It may take a bit time to just show up. Anyway, while we are waiting for that, this since it is open now, we can now see the files that are sitting there, and now we have the delta log for our data. In the JSON, we can see when it was committed and how it was actually what is the latest data. And in the metadata folder, we can see the metadata on top of the files here, and it is going to be actually a reader of our data in the KQL database. So it is going to be our the Parquet files are going to be available as well. While it was busy just writing them to the Parquet files, the actual files, the actual data, I mean, and the delta log as well. And here we've got the metadata, which is the Avro, the text, JSON metadata of that, the versions of it, and we can just have a look at it and see, for example, it has the list of fields available in that table: street, some number of bikes, and and the other things that we have here. Cool. Yeah, it is good to know how you can make it available in your OneLake for a table. The other thing is that you can make a database here from scratch, a new one, or a new shortcut database. The shortcut database, it's going to be shortcut KQL1, let's say, and then it is going to just selecting the available event house databases, KQL databases within my workspaces. So it can be just something to this monitoring database, or that one, or whatever that we have. Let me check. And we also have a cache policy for how long of data it can be retained. The data is going to be stay there for caching. But there is some issues with the. Let me just check if I have any permission on this database. Event house endpoint. Just wanted to create something. Yeah, and the cache policy is the days that we need the data for when creating the shortcut, and just always keep the cache up to date for us. The default is 36,500 for is the maximum of that. So however, if you're only, for example, interested in the for the past year, for example, we just say 365 and create that. Okay. So I think we're good also on it. We will walk through each of these items in the hands-on practice for the materialized views, functions, and we will work on the KQL query sets as well by creating the new table and just working on that. Anyway, you can, it is the shortcut that we've added, the shortcut of this guy, anyway, there is no table in it. And the only query set actually that we have is available here. It was just a sample one. It was not a big, actually any functional event house database. Yeah, let's go to our event house, the DP-700 my event house. So it was, one of the ways to create a shortcut to another KQL database. And here in the shortcut, as we have done it yesterday, you can create the shortcut to the tables in your or the folders even in your external resources or in the internal sources. I chose the fact order table from my data warehouse. And I can just access this one. And if you remember, we just queried that, and it is going to be actually identified and considered as an external table. What else? Yeah, the materialized views here are basically when we need to basically the philosophy behind that. When we need to have a pre-calculated set of data and you needed to keep up to date, the materialized views are going to be very useful. How it does work, basically, it takes your script from your table, and you don't have to just query your table always for a set of aggregations or filtering, even whatever that you're working with. Then you can create your materialized tables, and it is going to just get the that aggregated data for you. Plus, it is going to be the materialized part of your data in the table, and in the time that the difference between the last time actually of it's syncing with your table, it is going to just partially direct query or getting the delta for that specific section that was missed, to just cover your data as a the full set of your data and updated data to be shown in your materialized views. And the function is going to basically it is going to be a scalar function or the table function that is just doing something for you, preparing and returning data that you need, or actually functioning with an input and output. So we will practice this as well. Is there anything else? When you are on your KQL database, there are some possibilities that you can create link it to a real-time dashboard, or opening a KQL query set, or creating Power BI reports on top of this KQL, or even open it in your notebook. For example, if you open it in your notebook, there will be a connection to your KQL database, and it is not loaded. Yeah, now it is loaded. So there is a Custo URI that is basically the URI to your KQL database. I mean your event house, and the database name underneath of that is called this guy, and you can just run this query against this database. And the getting the token is used by the Spark utils. And yeah, that's it. Very straightforward. If you are a fan of PySpark and Python, and you want to still navigate your data in the notebooks. Okay, this session has to be started to be able to get the data from here. Yeah, it's just giving me that data. It is only for take 10 of that, of the bytes, the records in the bytes. It is a sample, you can just move forward with it. We just working on your notebook. Let's back to our event house. And yeah, you can, create the Power BI reports or viewing the files behind that as we covered for this table. And what else? Is there anything else that we need to discuss? And in the database level also, you can just, connect with them, or getting data from whatever sources that can be, that are applicable for a, event house database, a KQL database. What else? Okay, I think we're good on this. And let's start with some KQL querying to save more time. So what I've done, initially, I've got a set of script that we can execute here, right? What it is doing, so let me do something. I may have to split it. Okay, before we jump into here, in a KQL language, it is something that you need for DP-700 exam, but there is a KQL. Let me just bring it up. KQL query tutorial. You can find it in the Microsoft Learn page, Custo documentation. There are some short getting started, and also the query language, whether that are there, and what, for example, functions or commands or keywords that you've got. You can always use this as a reference for yourself. Anyway, we can start with this guy. So here, in the very first step, we are specifying some sort of variables for start and end date of what we have. We may need it. Let me just take a copy of it for the next sections. But anyway, when you actually execute it, it doesn't like it. So I'm gonna just put the ignore the variables later, and maybe just copy it. Okay. It is on to 12. Okay, cool. In order to create a table in KQL, it is going to be started with a dot. And if you type dot, it is going to just give you a list of items that can be started with dot, right? Like, for example, for this, if you start, typing, there's an intelligence for it, and with the create, then table, like we have in the bottom. So you're not going to copy that. It is listing the fields, the name of the table, listing the fields, the type of them with a delimiter of, comma between the columns, I mean. And yeah, you can just create it. Let's see, it is created now. You can see in the left side, the raw sensor event has been added. So the table that we have is going to just simulate a list of devices that the sensors actually on top of devices that are going to be streamed to our KQL database. There is an ingestion of the data. You can see we have the a sample data naming the columns in the first line, and then in the lines afterward we have the values from 1 to 15. And for the ingested add, for example, it is using a date and time function as now, and a specific date and time for the event time, and it is just capturing the temperature, humidity, the location of that, and the device ID, plus an event ID for just having a sequence of that. So this ingestion, this ingest inline into this table, then this table now should have data like this. Let's back to our query set, KQL query set, and see what else we have. Number 3 is just creating a scalar function. How we're gonna create a function here. Anyway, you always have the the option to make use of the templates, right? Remember in a SQL editor query, you had the same story, the same feature, and you also have the same here in Event House. In the database section, in the menu, you can just say new, for example, a function, and it is going to just give you the the syntax and the script to creating a function. However, something is up, and we can create it. So it is going to create a function. There are two basically input, and just a name of that. Basically, sorry, the input is the temperature, basically, and it is just providing us with an indicator of what temperature is it. It is cold, normal, or hot, or unknown. It is just a simple scalar function, basically, only returns 1. So it is created, and we can see that underneath of our functions, and there is a folder for it, as it is indicated in this guy, and we have the function here, right? We can just show the function script here. There is a KQL again command that we can just run it and see the body of it, which is the definition of it, and the doc string, for example, was a description of what this function is doing. Cool. And number 4, we are going to create another function. That function was temperature band. It was categorizing the temperature and identifying the type of that, the level of it. The other one is latest event per device. This one is a tabular function. It is going to return a table for us. It is basically executing a KQL on a table. The table is raw sensor events, and if we executed alone, then it is going to just return it, per device, the maximum event time for this one. It is going to be summarized by that device ID. Yeah, and then we can just create this function as well. Now this function is a tabular one. That's good. With the same story again, in the new folder that is created as analytics, and now we have the function there. We can just use the same show function definition. Just for querying our data, as we actually talked about yesterday, you can just start with the table name that you've got, and then with a pipeline, you're going to just initiate a new line, a new condition, or a new shape to your results. For example, the project is just selecting the fields that you need, and here, if we go just one by one, if we don't actually select anything, and if we only execute the raw sensor, it is going to give us all the fields. If we select it with the fields, then one of those fields have been removed. Or if we add the next line for just sorting that, it is going to be ordered by event time, descending. And we only are interested in the top 20. However, it is, I think, less than 20, if I'm not mistaken. Yeah, we can just make it as take 5 to make sense, right? And we can also, filter our data, by using the where clause, where, for example, the event time is between this date and time. However, let me check if I can just copy it because I execute them one by one. Let me check if, yeah. So it is a where clause. The event time is between start and end. We have specified this guy. And there is a command called extend. Basically, extend is used for adding a new custom column. Here, for example, the temp band, it is using the function that we have created by passing the temperature field. The temperature field now is returning the category of it, if it is normal, hot, or cold. And the other one, temp in Fahrenheit, it is in centigrade. Now we want it in Fahrenheit. It is going to just calculate our temperature from centigrade to Fahrenheit, and then we can just choose the columns and also ordering that. If you notice, it is doing the filtering very early, right? It is one of the optimizations that you may need when you're working on the performance of your KQL script. Or the other example here is just adding some sort of aggregations, right? The aggregation is keyword is the summarize, and then we can just give it a name for each field that we're going to calculate. For example, average temperature, it is going to just average the column temperature, and it is rounding by 2. And the maximum temperature, minimum temperature, and average humidity, and also the count of all, regardless of what we have. And it is going to be summarized or basically aggregated in different shapes by the device ID, location, and the more important one here, the bin is basically at the window, at the time window that it is for every 10 minutes. For example, for every 10 minutes for this device ID and location, aggregate the values for me and order it by the event time. And if we execute it, it's going to just give us more data. And if you look, for example, here, we have, if we only look at the device ID of def2, let me add it here where device ID equals to dev dash 02. Yeah, for the device 2, now it is, actually the event time now is for every 10 minutes. And if we remove this section, for example, then I'm not sure if it works like this. Oh, the event time is already added here. Or if I say, for example, every 30 minutes, then it is going to be decreased, because the event time was in different timestamps. And just to see what we have in the timestamp, let me just execute it like this and see how many records we've got there. What are the the event time? It was started from 10:07 up to 10:35. So in each 30 minutes, we had basically 2, right? 1 here and 3 here. Okay, so anyway, we can just get rid of this. We may need these variables later. The next one, next practice is latest state per device using the tabular function. We have the a tabular function that we have created. This tabular function is basically providing us the latest status of each device. If we go back to execution of this guy on top, what was it was doing? This function, it was selecting the records from this raw sensor events and just summarizing by device ID, summarizing everything by device ID. Then in the bottom, when we want to, where is it? When we want to just use that function, the function which is returning a table, now it can act like a table, and we can just add the columns to that. For example, extending by adding a new column called temp band, by using a scalar function, by passing the temperature, and just projecting the fields that we need, and like this. So if we just execute it, it is going to just give us the latest values. For example, we only have one record for def2 in Toronto. And the next practice is basically creating a small data in memory. Which is not persist in the tables, to just practice joining. And here, this data table in memory, is the device DIM, that has a list of devices. We have those devices that we have there, and they have been assigned to an owner, for example, team A, team B, and on the other side we have the the device type. For example, thermometer or thermo micro. Then from the function that we have as a table is going to be actually executed from there, basically extracted from there, and joining with this table variable basically, and it is going to be a join of the left outer join. If we don't specify the kind, it is going to be considered as inner join. So it is a left outer join on this table, in memory table, and on device ID. So the device ID is available on both tables, and we need the these columns. The device ID is coming from both. Owner is coming from this data in memory. The device type also, and the rest are coming from our persisted table. And then ordering by the owner and the device ID. So when we execute it, it is going to just give us some additional information like device type and the owner. So it is for joining. Oh, my apologies. We need more. How I can. Let me check if I can. Unfortunately, yeah, it's better. I hope it is better for you now. Isak, sorry, I forgot to zoom in. I know it is a bit hard to see that. Okay, so I hope it is good now. So I have to make it a bit smaller, or let's have more space here. Awesome. The next one, the latest state, we talked about that. That's good. For the IoT and for joining, we talked about this as well. Just for a KQL database, not only the KQL database, basically the KQL language and the real-time intelligence is very sometimes famous for just finding the anomalies, right, and just detecting them. And here is just a quick example to identify them. Let me bring my variables here, and let's see what it has for us. For the anomaly detection, the table, the where clause is just for between these two, start and end date. It is summarizing, very normal. We have done it before. It is just summarizing them, joining with itself. It is joining with itself, where the time is also between the same time on the device ID, right? But where the temperature is greater than the average that you've got plus 2 on STDEV. So what STDEV is doing? Let's check. It is something that I would like to check in KQL. So STDEV is calculating the standard deviation of expression. it is a formula like this. For those guys who are interested in calculations and these kind of formulas, yeah, you're more than welcome to do that. But mostly it is for data scientists. But anyway, it is good to know how that KQL can be utilized for different teams. Anyway, it is going to be just some anomaly detection, and on that device, and where the temperature is higher than average, then just let us know in that one, and it is going to just return something. Nothing was detected. That's good. There was no animal thing. And what else? Just create a summary table and populate it from a query result. Yeah. Share the data set. What's that? Can you please share the data sets or Kafka streaming links for practice and share other details? I can share this, the practice file for you, but not the Kafka streaming links, because that one, can be something created by yourself. Yeah, math is the building for, if you like to have it. So let's continue with this. We are creating another table in order to just get the data from a query result and just push it to another table, right? We are now creating a window summary table with a normal list of fields. Then, in order to push data, we can use the set or replace for your data, right? For your table, and it is coming from the raw data that we have. So if you need to just summarize your data and push it to your next layer of your data, then you can use this technique, right? And this command of set or replace the new table, and then the calculations that you're gonna have, then it is going to be loaded there. Oh, where operator? Oh, I need my variables here. So this variable to be added here, and then is it good now? Yeah, there should be a space between the previous. So these are the things that we need to understand between the blocks where we've got a new command of this guy. There should be a line in between. Still incomplete fragment, unexpected. What is it complaining about? Let me include it. It was terminated there, maybe. It is complaining about this where clause. Let me just get rid of this where clause. Okay, cool. Yeah, the data now is added there, and we have read from a table and just loaded to another table in KQL. And we can see that table and the fields here. Cool. Query the summary table that we just loaded. It is very normal, nothing specific. However, we are counting the total, for example, samples per device. The next thing, as I mentioned, we can create the materialized views, right? And in order to create materialized views, you can just hit it from here to new. Again, it is going to give you the code, and you have to complete the code. So you need to know what is the syntax of that, and if, for example, from the top or from the bottom, I hit the materialized views, it is going to just give me very simple version of that. Just create materialized view, a name of that, and on what table. So you can create your materials table on one table, and then your aggregation or the statement that you want to be materialized from that table. However, there is a the backfill. The backfill means just it is basically a default value, of course, to just keep it up to date. And this doc string, like what do you call it? Documentation and a description for your mat view. The name of that is device metrics every 15 minutes. For every 15 minutes, I mean, in the window of 15 minutes, where the bin is basically specified for every 15 minutes, and the rest are just on what table, and then we can just write our query as we expect to be seen in the materialized view, and that's it. We can just execute it and create our materialized view. Let's see, what is it complaining about? Bad request is invalid, cannot be executed. Aggregation round is not okay. This aggregation round is not accepted. To just not round it. I don't want to round it for now. Let's keep it working. Hopefully it works now. If it doesn't like the round function, yeah, all good. The data now is available in our mat view, and when we open it, we have a mat view here. We can just click on it, to just read the explore the data in it. This is my mat view. You can, of course, do the filtering like a normal table. However, as I mentioned, the important thing about the mat views is the materialized part of your data or the delta data. That in default it is giving you both of them combined, but you can using a function to only get the materialized data. There are some optional things. If you would like to drop a table, you can do that like this. Dot drop your mat view or the table, the function, whatever that you have created. You can do that. For the update policy for each table, let me just open the table. Where's my table? This one. There is a update policy here. Where is it? Yeah, data policy. It is for the retention and caching. For the retention, we can specify the dates that we want to keep the data for. By default is for 100 years. So if you would like to have the whole data in your KQL table, so you're more than welcome to do that. But you need to keep in mind, streaming data is an ongoing thing, right? Maybe every single second every millisecond something is just sent to your table. So if you want to keep it light, you can specify a policy for data retention. And for example, here, if for the table of for example bikes, we can just check the row count for now. Up to now is 53,000 of your table. So it is good to have a look at this view as well. When you click on your table, it gives you some details about what was the original size of your data and what is the compressed size of that. So you can see it is compressed and it is fantastic. It is 1/5 of the whole one when it is going to be basically compressed in KQL. And the one lake availability, we can make it enable or disable when it was basically enabled, and there's a latency of 44 minutes. Seems it is not going to be available right away. We need to check more details about this guy. An overview of the table, the count of the rows that you've got, how many in the last 24 hours. So after a while that you have your table, you can just find out how many data is getting ingested in your table in the every 24 hours, and when was the last ingestion date and ingestion URI. And yeah, some information about those caching policy and returning policies and whatever a related element. So it is going to give you an overview of what you have in your table. Plus the data activity tracker, how many records have been loaded. Since, for example, for 22nd it was 17,000. Today so far it was 28,000 records have been added to my table. And yeah, some information about the schema of that, and how it does look like. For example, for it is going to just give you some sort of column profiler view, just giving you some insights. For example, each for example, each street, how many records you already have in your system, or what is the some number of bikes. It's just top 10 of them is something like this. Yeah, just give you some information about the fields that you've got. Let's back to our KQL query set and see if there is anything that we can add. For the update policy, yeah, we just talked about that one. However, it is let me check if there is anything that is going to be useful. Yeah, I think we're good. There's going to be just some sort of enrichment of the data where you have, for example, just think of medallion architecture again, right? You have the bronze layer, silver layer, and gold layer of your data. The raw data is coming through, and when it is going to be updated, something is added newly. You want a trigger basically to make the other table updated, right? It is going to be happen something like this. Basically with that update policy, it is going to automatically populate a device table when data arrives in the source table. Source table for us here is the raw sensor event. And, we basically keep our, raw table immutable and automatically maintain a cleaned or enriched table, which is going to be our enriched table. So the same table, let's say, is going to be created with the same schema, but with some added, fields like this temperature band to just identifying, its category. And then, the update policy, query, it is just, the query that we are looking at. Plus, then we are going to just alter the destination table when it is going to be updated. Basically, its source is, we are just identifying, we are defining a policy, update policy for our destination table that's just giving it your source is the raw table. The query that you've got is like this, your, the query actually that we were seeing was something like this, this just projecting the fields, and it is enabled, yes, and it is transactional. So did we create the table, or the enriched has been created? Let's check if it is going to be executed with no problem. So there's some issues here. I'm on the other side, I'm not sure if the update policy is applicable for these tables here. However, it is complaining about this guy cannot parse it. Yeah, we can check it. I will check it later, and if I find anything, I will share with you guys later. Yeah, then it is basically the theory of that when that update policy is going to be created based on this source. I hope this update policy query is not just here. Anyway, based on that source, based on that code, the update policy is going to be showable here. Then we do an ingestion to our source table, which is the raw data. And then we should expect this new device data in our enriched table. So it is like a trigger that when this table has been updated with a new record, then we should have this table to be updated, to have the new one. This kind of replication, or the triggering. Cool. I think we're good. We're good on it, and I think we've spent more than an hour on the KQL side. Cool. Let's back to our slides and cover the rest. For monitoring and optimization, and why it matters. In each basically organization, we are always thinking about maximizing the performance and efficiency, and they always looking for just decreasing the cost and controlling that, right? Money matters, and how they can just manage their resources and their allocations, and just having more basically as a total understanding the issues and having the best practices in place for each of the resources that they are using. Yeah, same as the previous slide. It is also just talking about when we do the monitoring and when we want to benefit from all of those optimizations, we want to achieve. Actually, we would like to achieve. Just be able to scale our resources and our solution, and reduce the risk of data corruption or loss, improve user experience, maximizing your capacity and the available resources, and having some automated alerts that are going to be available by the monitoring and optimization. In order to monitor, the Fabric, solutions, there are different, places that you can, and different items actually in Fabric that you can do the monitoring on top of them, like data pipelines where we have the orchestrations of the tasks to just check the items, the activities there if they went well, or for the data flows where we read the data from source and doing our ETL, and for when we are actually refreshing our semantic model after some data refreshment, or the Spark job definitions that are up and running, or the scheduled notebooks, or the notebooks even that are executed as part of the data pipeline or the Airflow. And also the same story for lakehouses and the event streams, if all are working well and there is no error. So the best practices, for monitoring is basically identifying what you're gonna monitor, right? You need to know the whole structure of the whole architecture of your data solutions to understand where and what should be monitored and where you can do that. How you can collect and review your data, and if there is any issue to be identified, knowing that issue and how to resolve it, and eventually you come up with some optimization and performance improvements. And it falls in every single items that we've got in Fabric. Not only Fabric, any IT-driven actually solutions. In Fabric, the very first place that we face with is the monitoring hub. In the homepage, you can just find it. You can just look at the activity status, start and end time, the duration of that, and activity statistics. Let's have a look at that in the portal. In your homepage or any page that you are, there is a button here as for monitor, and it is listing all the items that have been executed in your Fabric capacity that you have access to for sure. And in the filter, you can just make use of that. You can specify what status that you're looking for. Are you looking for only for the failures, or you want something to see not started, why it is not started, or why it was canceled? For example, if you want to check the canceled ones, for example, I had a Spark job definition that I canceled that because I didn't want to keep it running. Or even for the item types, you can just filter on that, and you can see what items that you can basically monitor in this monitoring hub, and whether that is related to the data engineering, it's going to be your use case. By the way, while I'm seeing here, we have the user data functions. That is also one of the things that you need to learn about. Actually, we haven't covered that in our presentation, but keep in mind, just read about this as well before the exam. And one more thing, the digital twin builder is is basically the way that we can model the data in our real-time intelligence, and in the even actually real-time hub. We can create the model and then just doing the reporting on top of that, and the other stuff, for the item types that we've got here, and you can just specify, for the time period that you're looking for that data, and who has submitted that, and also the workspace, basically the location of the item that you're looking for. For example, I'm only interested in the DP-700, database workspace, right? Cool. And there are some columns that you can add to your basically to your view. And for example, I have added a column called upstream run, and it shows where this item, for example, this notebook, of my data warehouse notebook 1 was executed by as part of this pipeline, and I can just also check the execution of this pipeline. So yeah, and the other thing, maybe for the lake houses that you've got, you can also check what resources were allocated to that, right? For example, 8 core and 1 executor. And the other thing for a notebook, for example, let's say, for example, I have a notebook here for loading the orders, right? You can, check the historical run of this, or even you can just click on the executed item. It is going to just move you to another page for more details of what was the steps for that notebook, what was the jobs that has been executed there, the status of it, and from here you can even go to the Spark History server, or by clicking on any of these guys, it is going to land you to the Spark monitoring part, right? The section, Spark URI Fabric, that you can see the jobs, you can see the stages, and more information about your Spark engine. And for example, here it is just visualizing DAG, DAG 1, that how it was started. You can go for more details and just learning about what you need. For example, even the resources that was allocated to this, and what was the duration of that, and if there is any failure, you can look for them here and also here. However, these were all succeeded, and you can just check the resources, for example, that was allocated to that specific notebook when the Spark engine was created. For example, here we can see initially 8 vCores were 8 nodes were basically allocated to that, and at that time nothing was running. Then it was all idle, and we only had 1 running, for example, at that time, or how many jobs and were actually assigned to that node for the and for how long the Spark session was actually lasted there. And for example, here you can see 30 minutes. As you know, the timeout for a job Spark actually engine is 20 minutes. So we might have increased that for 30 minutes, and that is why we have this total duration of 30 minutes. Yeah, and you can also find the number of driver cores and executor cores, the type of that node, size of that node. That one, for example, was medium because it was the starter pool, right? And yeah, these are the things that you can just find out for a Spark notebook that was executed. Just find it out. The other thing, for example, you can look for this copy job which was failed, right? And we can see what was the problem of that. And it is one of the things that we need to, as a data engineer, we need to identify the failure. What is the failure? We can just look for that, or finding that failure in the community if it is not in our expertise, or it is actually a known issue. Then we can just find a workaround. What is it talking about? For example, here is the data is actually the error is ADLS Gen 2 failed for forbidden. So this data is not available. Maybe, and in most of the time, the issues may be coming from the connection string or the connection details to your source. So it is not always, the mapping or something like that. But you need to, keep in mind how you can drill into each of these, logs and check them. And here, for example, if you go through that, you can see the source of that is a ADLS Gen 2, and the destination is a lake house. Did it read any data or not? If not, what was the problem when it was started, and what was the error? It is the error code which will be useful for you when you want to investigate and find the result in your Fabric community or in the documentations from Microsoft. So that's good. And the other stuff, that, for example, for a pipeline, if you go through the pipeline, also it is going to land you basically on the activity run, right? The history of that. You can see, for example, it was the thing that I think we have executed yesterday. 2 of them were inactive. The other one was active. It is a notebook. If you still go through that, it is going to just give you more details about the Spark monitoring URL, the cluster status, and the snapshots. That the one that we basically could find in the Spark monitoring section as well. Anyway, when you are working with the pipeline, there's always an input and output for each activity. How long did they take time? It was successful or failed. If it is failed, you're gonna just find out the issue and then resolve it. And if there was any input, for example, for this one, the input for a notebook, it is an ID for the notebook and the workspace that this notebook is actually belongs to. And the output of that will be just a successful message that, for example, it was completed. The Spark pool that was used, but it was this ID and some sort of, more information of what you can benefit from when investigating, basically. So as you can see, it is really, really wide and broad discussion when we talk about the monitoring section. The other thing, let me just check my slides if there is anything. Yeah, we went for the demo. Before I jump to this discussion, there is, basically the items that we always check are, for example, for the data ingestion. For the data ingestion, we know that pipeline is used for it, data flow is used for it, or refreshment of a of a semantic model, for example, is also is using the same basically main method of data ingestion and data loading or data refreshment. So we can check the latest runs or activities for each of these guys. For example, for the my pipeline, I can just look at the recent runs to see if all was successful. If not, I can go to the monitor and just view that here, only for this one, to give me more information about if there was any upstream run or not. Let's back to this guy. And the other thing, for example, for one of the data flow Gen 2, if I go for the recent runs, again, it is for the data flow Gen 2 this time, it is going to just give me also the same history of the latest runs. If there is any, there's only one. However, you can just download the history file and just some more information of how it did go. Anyway, there will be the tables, and some more details actually in your data flow that is going to list the tables, the activities that you had there, and so anyway, you can download the CSV and you can just check the CSV result. I cannot show it here for you because it is in my other screen. That's fine. It's not a surprise. It is a CSV that you can just check the details. There's an app built by community called basically Fabric Capacity Metric app that it can be installed in your workspace, workspace, and connected to your workspace to check the usage of your capacities. It is an admin tool for sure, but it is one of the things that you can also benefit from if you would like to have an overview of what's happening. The capacity units have been used, for example, for a Spark engine or for notebook. We can just check them here as well. When it comes to monitoring, we are looking for something to improve always, right? The first thing is going to be the optimization, right? The optimization is in the optimization, your focus will be in maybe three sections, right? Storage, compute, and processing. For the storage is where you're storing your data, lakehouse, data warehouse, or databases, SQL database, or event house that you have. For the compute, you can just think of Spark or what you have. And for processing, maybe the event streams, pipelines, I don't know, whatever that is related to that, like, data flow Gen 2. We need to keep in mind that, Fabric basically connects, through one lake, everything through one lake, and we have everything centralized in one lake in terms of the storage. So we should always think how we are, we should actually do our optimization for the data loading and processing to make it accessible for every single engines as much as we can. So it is a long process basically, but it is not a quick thing. But there are some hints that we can provide here. For example, when we are working with the lakehouse tables, the delta tables, there are some techniques that you can use for your delta tables, like view order. The view order is a right time optimization that it is going to take a bit longer for writing your data if the view order is activated for your table, but it will be very useful when you want to read the massive data from there. And how to do it, let me just quickly go to my Lakehouse. And one of the tables that we have here, for example, this one, we go to the maintenance section in a Lakehouse. We go to the maintenance section, and we can, for example, optimize our file. It is going to just optimize it. This optimization is basically doing two things. One is compacting the files. If you have fragmented files for same table, all of them they are going to be consolidated in one large file, up to 1 gigabyte, let's say. And then and the engine, actually Spark engine, instead of just opening different files, it is going to only work with one file for number of records. And also we can apply the V-order to optimize reading speed in Fabric. However, as I mentioned, V-order is a write time optimization. And yeah, that's it. And the other technique is for maintaining your tables in Lakehouse is removing unreferenced files by executing the vacuum command. And this vacuum command is recommended. You can have this threshold, the retention threshold of 7 days or whatever days that you have, but the recommended is the maximum, actually the minimum day that you're gonna have is 7 days. And it is because if you want to travel in time actually, and you want to have the your previous values of your data, just don't go actually less than 7 days. It is just a recommended one. However, it is going to just run it, and this optimization is going to be executed. We can have this execution of these commands as part of your notebook, and just make it as a scheduled one, right? And you can put that as a step in your pipeline even, right? So one of the techniques for data lake optimization is V-order optimize command, vacuum, and also Z-order clustering for faster queries. Z-order clustering is going to be done on some columns that are basically used a lot for your querying. You should think what column is the more actually filtered for your reads. And the other technique for optimizing your storage in tables is enabling the partitioning and caching to enhance actually read performance for large data sets. In data warehouse, you can just analyze and adjust table storage format, the data types, the list of the fields, whatever that you need, really bring them to your data warehouse, and not and always avoid having unnecessary fields. You can use column store indexes for efficient analytical queries, and always monitor distribution keys and partition strategies to balance performance across nodes. Let me just make it more bigger a bit. Yeah, and when it comes to optimizing the compute and processing, we can just have a look at the pipeline. It is important that you limit the activities that you've got in your pipeline, like the transformations, and just think of just processing the activities in parallel when you're working with the pipeline, if it can be, and just releasing the resources sooner. And you can benefit from incremental loads instead of full loads always. You can make use of copy jobs, or even the other things that is going to be, for example, in a data flow gen 2 for the incremental load. And think of the 3 years of your pipeline. If it is better to have the event-based 3 years, or the scheduled one is going to meet your needs, and how many times the schedule of the data is going to be useful for you. If, for example, the business and your clients only is interested in seeing the data at the end of the month, why we should call the data, for example, every week, or if we can, for example, aggregate our data in the source and then load it to Fabric. So just think of how you can push more pressure on the source rather than what you have in your data solution Fabric. In the real-time data, which is the event stream and event houses, it is a general recommendation that you need to reduce the data volume with actually filtering and transformation in the ingestion level, and just using the time windows to group streaming data efficiently. Like what we had yesterday, we went through a windowing of aggregation windowing. Actually, in the Spark compute, you should think of optimizing the cluster sizing based on the workload needs. For example, if the auto scale is required or not, or how many as an admin or the data engineer who knows the admin things, you need to think how you're going to allocate the resources for each Spark pool, or what type of node you're going to specify for a workload. Are you going to choose basically are you going to having a I forgot about this. About the size of your actually Spark pool, you need a big size of that. It is going to be large, extra large, or medium, or even the small one is going to just meet your needs. Or do you need really more than one nodes for the the processing that you are doing, or it can be just wrapped up in one node? Just think of them. And so about the partition size, just it needs to be tuned. What partitioning type, or what column you are going to use for your partitions? Just think of that. If you can cache it or broadcast joins in the query optimization in Spark. And about the SQL query optimization, so just think of the materialized views and how you can pre-calculate your data just for those frequently queried, for a better performance, and not calculating the same thing several times. So you can think of that as well. Indexing and query hints is fantastic, when it is applicable to speed up your query executions. If there is any filtering, if there is any join between the components, actually objects that you have in your warehouse or in your data store, and just optimize the query patterns, reduce the joins, and push down filters to streamline queries. It is always recommended that the less join, more performance benefits in the result. And you can just monitor query plans. You can use the Fabric's built-in tool to monitor it, or even for your SQL, you can use the SQL profiler in your SSMS to just understand what's happening with your items. So this one is a quick cheat sheet of each of the items that we've got for monitoring, resolving the issues, and optimization per items in your exam and using Fabric. So for example, for monitoring data ingestion, you can track the data arrival from sources, review pipeline run history. I don't want to read all of them, more or less we talked about these guys, through our conversations, but here is the list that you can just take a screenshot of it, and you can just use it as maybe a reference for a quick cheat sheet. So what is the rest about the security and compliance? The security is not part of the DP-700 as far as I know. For that, actually, as an admin, but as a general, we talked about some security stuffs, that how the Fabric is integrated with your Microsoft Entra ID tenant, and there is some isolations when basically there's a multi-tenant, and the admin of your Entra ID is going to restrict the access to each tenant, and that's it. That's very obvious that you can just specify members to have access to what domain of Fabric, or what workspaces, and what level of the leverages actually privileges they have. Anyway, the next item for the data security is the encryption address. Data stored in OneLake is always encrypted, and however, the organizations can bring their own keys for making it more secure, and it is here. For example, in the workspace, the workspace setting, you can I think it was in the encryption section, you can apply customer managed keys, CMK, and anyway, it can be brought here, and just working on that. And it is not available in all regions, and also for the Fabric trial version. Cool. And yeah, Fabric promised for the data in transit is encrypted, and with the TLS communication. Yeah, and also we have the granular permission restricting to data and resources using the role-based access control for the items. And in terms of the the data compliance in Fabric, there are some the regional data storage. That data is address is stored in your home region or in remote region of your choice when you are basically purchasing your capacity and tenant actually, and how it actually acts for the multi geo tenants, how the data is going to be stored there, metadata and processing securely managed in the tenant's home geo, and the compliance certifications, it is meeting the standards of Europe and in America for the GDPR there, and some stuff like that. And for the auditing and monitoring, you can track always access and changes to enhance governance. And there are some possibilities of the private endpoints, which you can just secure the network level isolation through Azure Private Link. For the monitoring again, we talked about I think everything, and we covered, where you can check the monitoring and logs. So it comes to an end for the section that we were supposed to complete about the optimization of the the performance for a lakehouse table pipeline, data warehouse, event stream, event house, Spark, and query performance. We should be good in order to identify and resolve the errors. We talked about them, and even during our bootcamp, we actually be faced with some issues together, in the level of development. So it is good to know how to identify the issue and where to find it. It is in the monitoring section, the history log of each of those items, and how to monitor them, and if they have been, for example, your semantic model has been refreshed or not. Oh, for the configuring alerts, let me just quickly go to the portal to not missing that. In your event house, as you remember, we could create the real-time dashboard, right? RTDs, based on, let me just bring it here. And then you can, just save it to dashboard, as a new tile for a new dashboard or an existing one. However, we've got the dashboard here that we have created yesterday. And the data behind that is number of bikes per street, for example. And if we look at the data behind it in the edit mode, we can see I'm just checking if the number of bikes are greater than 10, for example. I'm counting it as a total number of bikes by street, and it is rendered as a pie chart, and it's shown in my basically RTD. And I can set alert here, or adding the new tile, or just adding other data sources. However, I want to talk about this setting alert. The setting alert is when you want to set the alert, you need to, for example, choose a tile that I'm going to check, give it a name for this rule, my rule 1, and here, every, for example, 5 minutes or less, it can be every minute, the minimum is every minute, to just check on each event group by, for example, group by street, when the total number of bikes changes, or you can even go with the other things. For example, you can say decreased by this number, or it is less than or greater than 10, for example. For what I have, it is greater than 10. Definitely it is going to be triggered. Then I can just say, hey, select action, message to a Teams message, or sending to an email address, or even running the Fabric activities. Like, I have created a pipeline, so when it falls in that number, it is meeting this rule, then run that a pipeline, or running a notebook, or a job, or running a function. And even you can create a custom action using the Power Automate. Then you can just make it very customized for yourself. But let's keep it simple. I want to just message to individual, to this user, and it is the headline, the note of that, and the context. For example, the total number of bikes is going to be added here, and it is going to be created in my activator. I have an item in this workspace called my activator, or I can create a new one if I don't have. Then it is going to be created. So it is the triggers. These triggers and alerts actually is alert that we can create on this, and we can open it for sure to just see the history of it and what happened to that. The my rule one, this one, for example, it is supposed to be executed every minute, or this one that I have created before. Let's see if there was any, the history of this, I have executed this before. Total, activations today, 192 times it was actually, activated, right? And now I should have this number of, messages in my basically a Teams message. And here are, the rows that, for that, activation, the total of it. And it is going to be a real-time, alert. So anyway, I'm gonna stop it. And that's cool. And also for this one, let me stop this guy as well. No, however, we have just executed that. Every 1 minute, it is going to just identify the records and just send it. The question from Isaac. So alert is creating the activator. From alert, we can create the activator, but the activator is basically, the activator, and in activator we can create alerts, right? I think in the home section, it should be added here, for example. Yeah, that's a good question. Let's let me just check it quickly from our RTD. If we add something to an existing one, let me just set alert, same thing. Let's call it as rule 2, right? Every 5 minutes, go to the same thing, goes to the my activator. So the activator is 1, and this rule 2 street number of bikes changes. That's good. It should be underneath of that existing one. Nope. Yeah, you're right. It is creating an action actually in the activator. But if you look at the your workspace, you only have one my activator, and inside the activator, right, the type of that is activator, then you have the alerts there, right? So the alert is not creating the activator. You can create the rules in your activator. I hope it makes sense for you. Yeah. Oh, cool. So let's back to the PowerPoint, and actually, I think we should be good. The windowing functions, we've created that. We've worked on just, and yeah, awesome. Cool. Guys, it comes to an end. Sorry, we did not have time for going through the practice on I wanted actually to take this time to go for a practice on the notebook, but maybe I don't know if I may just have another, we can have another session for going through this practice, but it is going to be also a good one for some practice in the PySpark to just practice, for example, for the incremental load, how to utilize the PySpark actually for doing the data transformation, loading the data, and so on and so forth. Of course, you can find lots of resources out. And yeah, thanks again for attending. Thanks for your participation in these two bootcamps that we had at the Fabric Cafe. And just don't forget to let us know when you pass the exam, or you want to share your experience from the exam. The a YouTube channel, the Fabric Cafe, is always there. You can rewatch the past sessions, and stay tuned for the upcoming sessions in 2026. We have fantastic things for 2026. And yeah, don't forget to rate this session at Meetup. If there is any question, we can answer some. If not, we can wrap up the session. As I mentioned, I have the hard stop at 2 hours. Now I'm 4 minutes late. So yeah, mine will be the 31st of December. I didn't a month ago, but wasn't successful. Oh, no worries. For DP-700. Okay. Yeah, I will also, I think my exam is also scheduled for the same day on 31st of December. Yeah, we have still, a week maybe or more. Yeah, almost a week for practicing. Just you can check the other resources as well in the community from Will, from Alexei, from Nicola. There are some resources there. Just make sure watch them as well, and I always reference the Microsoft Learn documentation. I know it is huge. It is a lot to read actually, but it is going to add to your knowledge, and you can make benefit from that. Cool, guys. Good luck with your exam. And if there is anything that I can help with, please feel free to reach out. If you need any 50% voucher, still is some are left available by end of December 31st to be used. And yeah, guys, enjoy your holidays and Merry Christmas in advance, and Happy New Year. It was the last session of our Fabric Cafe in 2025, and wishing you all the best. Enjoy your time and keep safe. Cheers.